Excellent. Hey, welcome everyone. This is our part 3 of our Biocontrol Regulatory Masterclass. It's the last in the 3 sessions, and we're really lucky to have Roma join us again today for a fantastic session that she has planned for us. I'd also like to thank Valent Biosciences and Sumitomo Chemical for helping support this program. And we actually have people from Valent actually online today, so exciting to see them join us in the middle of their morning from the US. Putra is also on board. He's the project assistant and he's there to help us in the background. So thanks for that, Putra. And if you haven't already, please introduce yourself in the chat. We've got not as many people as last time, although we've already got 30 and that will increase over time. But that also means that we've got plenty of time for real discussion as well. So we're really going to probably be unmuting people and allowing you to speak later on. So get ready with your questions. I'm just going to move on to slide 2, Roma. And just remember that we're using the chat box really to ask all your questions, to share your thoughts and resources. Make sure you introduce yourself, which many of you have already done. Raise your hand if you would like to ask a question and you want to verbally say it, or you can just put it in the chat. But also you've got a reactions button down the bottom there, and that's quite fun. It actually gives some good feedback, particularly to Roma when she's saying something that really resonates with you. So put your thumbs up, give her a clap if you think something's really pertinent to you and important. It's a really nice way to sort of show your reactions and communicate with everyone. So moving on, I'm going to just go on to the next slide, and I can see already more people introducing themselves. Great to see people from Papua New Guinea as well. So nice to see you back. And this is just what you already know, which is really just make sure you interact in the chat, because it's a really nice way of catching up with everyone and finding out where there's people working on the same things. Now, this is the last part 3, and we're going to look at environmental fate and ecotoxicity. And this is really, while I say it's the last of 3, it's also the start of work in this area. So this is really giving us a sort of a basis to sort of look at where do we need to go next? Where do we need to provide more support? What kind of resources do you need to help you do your work better related to biocontrol and regulation? So we'll be coming back to you sort of with questions over the coming weeks. We'll also be putting together a nice sort of report and all the resources. Most of the resources are already online on the videos page. There's the copy of the videos from part 1 and part 2, and also the PDF copies of the presentations. But we will definitely come back to you with more. So without further ado, I'm going to move on to the next slide. And I think that's the start of Roma's presentation. So Roma, welcome back. I would just like to congratulate you on the series so far. It's fantastic. We've had amazing feedback. We've had a lot of people answering the monkey survey, which was around giving us some feedback on the session so far, and very high ratings and very a lot of people very happy and interested in talking further. So welcome and thank you.
Thank you. That's very kind words. Yeah, actually, this sort of is my favourite bit. This, of all the other things I've been through, this is the one that I really kind of enjoy. Maybe it's because I'm a biologist and this really makes sense to me. What we're trying to do. There's some other parts which I'm sort of sometimes think, oh yeah, okay. So I want to talk in this session. We've in previous sessions we've talked about the aspects of safety related to human health, and we've thought about you know, what the substances that we're working with are, what they look like, and how do we manage those. So what we're going to think about today is what happens when we put these products out into the environment. What is where do they go? What are the implications? Because our concerns are not just about human safety but environmental safety, and we don't want to cause unacceptable harm. So we want to understand sufficiently about the active substances and products that we're applying, so that when we're putting them out into the environment, we're confident that they're not causing unacceptable harm. So just as a little reminder, the substances that I'm going to really be talking about today are microorganisms, botanicals and semiochemicals, and I'll address the environmental fate and ecotox of these groups, these three groups, in the order that they're on here, which, so I'll talk first about microorganisms, then about botanicals, and then about semiochemicals. And I'm doing that because their environmental fate and ecotox considerations are really quite different. So part of what we're trying to do in this series is to think about what that regulatory process, and we know that if the regulatory process isn't adapted and doesn't consider these types of technologies and have skilled experts for these technologies, it can take a very long time. So if we look at somewhere like Kenya, Brazil, USA, where they've got a specific regulatory system, it takes a very short time. But we look at somewhere like the European Union, where it's a much more complex system, we can see that the regulatory process goes much slower. So what we want to do with this masterclass is to help the applicants and the evaluators to build the knowledge so that we can make this regulatory process go fast, because there's so much innovation and there's so much demand now for products that can be used in IPM, and these bioprotectants are products to use in IPM, that we want to make sure that regulation isn't an unnecessarily high barrier. But that said, we want to maintain a high level of protection of the human health and the environment, but not ensure there's extra barriers. And so we want to take a simplified approach. And this is what the WHO FAO guidelines took as their principles when they were developed. So the basis, the underpinning sort of approach that I'm taking for this series has been using this guideline because it's the most recent guideline, and it's probably the most thoughtful guideline on microbials, botanicals and semiochemicals. So why are these substances different? Just again, a little bit of a recap. They're very different to sort of microorganisms, obviously living organisms. Botanicals are complex mixtures and semiochemicals don't kill anything. So they're very different situations. So because they're very different, and because often they're substances which are really well known, a large part of the dossier can come from published literature and also sort of in-house studies of the mode of action and biology, which is something we talked about in the first session. So you'll see in a dossier, as an applicant, you should use this, and as an evaluator to see this, you'll see a lot of reason cases and justifications and waivers. And this makes it a little bit more complex in some ways, because you're having to read a lot of sort of good quality scientific literature. It's not just a simple study, this is the outcome of the study, yes, no. And when you're looking at dossiers that have been brought from other territories, it's trying to understand of that information that's provided, what's the useful information, what's the information that's in there to help me make a decision. An applicant should really be thinking about that, thinking about providing information that is useful for the evaluator to understand what their substance is, what's happened to it, so that they can make a good assessment. The other thing, a couple of things I just sort of want to think about these types of substances, so often these active substances are formulated with co-formulants that are inert of no toxicological concern, and this is because the developers don't want to that their active substance may have no classification. They don't want to have co-formulants in there which have a classification, and their aim is to produce products for people, for growers to use and farmers to use, that are not causing unacceptable harm, so they make sure their co-formulants comply with that approach as well. And the other complication is there's often no suitable or validated tasting methods. So what you'll see in a dossier as an evaluator is you'll see non-typical testing methods. And as an applicant, you have to be really thoughtful about how you design your studies, not just to take a list off a shelf somewhere, but really think about what your active substance is, and therefore what's going to happen to it, and therefore what studies do I need to think about doing so that I understand well the fate of the substance in the environment. To make life a little bit easier, the FAO are developing this registration toolkit. They already have the toolkit for chemicals, but they're developing it for microbials. So for the microbials, at least, there's going to be a lot of this information I'm talking about is going to be available online. Then eventually there'll also be the information for botanicals and semiochemicals. But it's a lot of work, so it'll just take a little time to get there. So we start to move into thinking about specifically the environment and non-target organisms. So I'm going to work with microbials. So in the other sessions, we've covered off identity, biological properties. We've thought about effects on human health and residues. So we've had in other sessions a discussion about efficacy. So today we're going to talk about the environment and non-target organisms. So just a little bit of a reminder is our ability to understand what happens to a microorganism in the environment relies on us knowing what is in that active substance. And just a reminder that active substance can be the microorganism and the secondary compounds it produces, or there's no secondary compounds, and then we're only thinking about what happens if the secondary compounds are produced in situ, as in the field. And that's true whether we've got a solid state production system or a liquid state production system. So with a microorganism, you've always got to think about what the microorganism is doing and what any secondary compounds are doing. And this isn't about having to understand all the secondary compounds, it's thinking about the secondary compounds or metabolites that are toxicologically relevant. So you don't have to understand everything, you just have to understand if you have toxicity. And some of the indications that you might have toxicity would have come from your human health. So that, so for example, when you've done your human health testing, if you have no endpoints of concern, there's an indication that you haven't got toxicity there. But it also relates to your production process. And so when you start to work with the microorganisms, you have to think about how they're produced. And the other consideration is WHO and FAO guidelines have said there are certain types of microorganisms which we know a lot about. And providing they sort of have these criteria, we may not even need to do the environmental and ecotox work. So that means if you've got a full and unequivocal identification, so you know that it's an insect pathogen, or you know it's a plant pathogen, you know there's a lot of good information, you know what it is. So you're confident in its identity. You have looked at the production process and you're sort of saying, well, look, I can tell from the production process, or that the applicant has provided evidence of it, there's no secondary compounds present, or there's no toxicologically relevant secondary compounds present. It's not been co-formulated with anything that is toxic. There's still viable material there. And there is still information on the phys-chem properties for the formulated product, and no human pathogens in there. That you could actually, you don't necessarily need to do present any evidence around environmental fate and ecotox, because we have an expectation. We know what these microorganisms will do, and we know how rapidly they'll break down and what their prevalence is relative to background levels. So it might be when you're evaluating a dossier that you actually don't even need to do the environmental and non-target testing, and that's something to think about. So to think about the environmental fate and to think about non-target organisms, we really have to understand very well the identity of the microorganism, and this is something we covered in the first session. And we also have to understand very well the biological properties. So we need to understand its biogeography, where it comes from, what ecological habitat it's in, what its mode of action, the life cycle. So you can't proceed with the environmental and non-target work without really reading and understanding these parts of the dossier. They're the key to knowing what to do for environmental fate and ecotox. And it's just a reminder to the applicants, it's why the biological properties part of the dossier for a microorganism is so very important, is you have to get that really done very, very well, because the environmental and ecotox evaluators will be relying on that information to help them make decisions about what to do. And another reminder that we're thinking about this microorganism, we're thinking about the microorganism itself and any toxicological effects from the secondary compounds. And again, it's not understanding all the secondary compounds, it's just any potential toxicity. So when we're thinking about environmental effects, we're looking at soil, air and water exposure. Now, if we sort of pick that apart to some extent, we don't really have an expectation the microorganisms are going to move into the air phase because they're microorganisms. The air is already full of lots of microorganisms. We breathe them in every time we take a breath. So we're not when we spray the microorganism out there, there's no additional exposure. And actually there's some nice research which supports that statement that I'm saying. And then if we think about the water exposure, there's two aspects to that. Is mobility in water, and microorganisms are not exactly going to move through the soil and into the water, but they might get there as spray drift or something like that. So what would happen to them in water? What normally happens in water is the microorganisms settle out. It's not the habitat for microorganisms. If you're an insect pathogen and you end up in water, you're just going to die. It may take a little bit of time, but essentially you're going to die. And you're certainly not going to find your hosts in the water. So a combination of sort of understanding the biology that you don't germinate in water, that the hosts for the microorganism are not in the water, and that they'll settle to the bottom of the water is the usual pattern. Again, you don't have necessarily a lot of information is needed about the water. So most of the information and consideration you'll have for environmental fate for microorganisms is consideration what happens in the soil. Okay, so it may mean that there's a minimal amount of environmental information that's required. Again, just emphasising that a lot of the information that's going to be coming forward is going to be coming forward from studies and not from the literature, and a small amount from studies. So something that I do sometimes is, if I want to see what happens in water and to confirm what happens in water, I'll do a simple study with a column, and I put some microorganisms at the top and look at how quickly they drop to the bottom, and then look at what happens to them there. And that just supports the information that's in the literature to say that the microorganisms performing the way the literature says, and it's justification for non-provision of specific study data. And it's also possible to think about the microorganism as to what environmental compartment it's in. It's not going to be in all the environmental compartments. So again, just thinking that you're not having to necessarily look at all the environmental compartments. So the approach that I take is a sort of, I think this diagram is really useful to help our thinking. It's a tiered approach. This is, I'm showing here the flowchart that's taken from an EU document, but this in itself was inspired by some work done by some environmental risk assessors. And I use this is to help my thinking as an applicant, but also to help thinking as an evaluator. So the first thing is, is there enough information? Is the mode of action and the microorganism characterized in a good way? And that's going back to that section 2 of the dossier to say, what do I have on the mode of action? And then the next part is thinking, okay, how is this going to be used? So where will it end up in the environment? Will it end up in water? Will it end up in air and end up in soil? And I've already said that ending up in air is unlikely, and ending up in water is not necessarily problematic. That said, as an applicant, you still have to provide that information. You still have to provide that reason case as to why that's so. So don't just leave a blank in that part of the dossier. As an evaluator, if you've seen that blank, the applicant needs to fill that in and explain to you why there isn't exposure, but what you'll expect to see is a reasoned case. And then we'll move on to sort of, if there's no contamination to soil and surface water, you can go straight on to thinking about environmental toxicity. But if you can't exclude it, then you start to go to box 3 and think about, okay, what's happening to this microorganism? Is it going to accumulate? Will it multiply? Is it going to, and what you're always thinking is it being applied, and is it going to proliferate in a way that there'll be more of it in the environment than you might find naturally occurring? And the answer is yes, there will initially when you make the application, but microorganisms don't survive well. Often they're degraded by biotic and abiotic processes, and so they rapidly degrade. So there is some calculations you can do to look at, if I put a microorganism out there when I spray it, how much of that microorganism will be there relative to what we know is in the background levels. And to get the information about the background levels, there's some scientific publications that explain that. So as a broad rule of thumb, when we apply a microorganism, you'll expect to find about 1 × 10⁻⁵, 1 × 10⁵ CFU per gram of soil. And if you look at the literature, say for something like entomopathogenic fungi, insect active fungi, the carrying capacity of the soil is roughly around 1 × 10⁻³ × 10⁵ CFUs per gram of soil. So what you know is when somebody makes this application, they're not significantly adding to the number of microorganisms that could be invaded in the environment. Therefore, they can't be an additional risk. And you'll see a lot of dossiers make this kind of argument. And it's only if the amount that's been applied is significantly above background levels or the microorganism will persist for a long time. So a persistence for a short window of time is fine, because you're not, again, having an unacceptable risk. It's when you've got its survivability at a high level for a long period of time, which would influence the microbial environment. But just again, thinking about microorganisms, when we put them into the environment, the soil is stuffed full of microorganisms. It's just, there's so much out there. There's a really nice piece of work that was done in Denmark, in fact, where somebody surveyed a field and they found 15 new species of Metarhizium in this one field. So what we do is we completely underestimate the population of microorganisms that are already out there. So the amount that we're putting out, you know, I'm saying it's carrying capacity of a microorganism for biocontrol is about 1 × 10⁻³ or × 10⁵ per gram of soil. But the number of microorganisms per gram of soil is in the billion. So the amount we're putting out there is really quite small. So you're bringing together all these considerations and sort of saying, so is there an unacceptable risk? Is there an unacceptably high level of microorganism going out there that I need to look at? So the applicants should be providing good information on how much they're applying, where it's going, what happens to it, and that'll mostly be done by reasoned cases rather than empirical evidence. So I use this as a framework for proceeding. And if we look at that FAO guideline, they've sort of broken it down, and they've got 2 slides that are related to this. So if you're an indigenous species, most countries have the rule that you can have a release of an indigenous species. So the species must have occurred somewhere in the country. Sometimes there's lots of evidence of that because it's been a topic of research usually. And other times there's not so much evidence just because nobody's done the research. So what the choice then is to go and look for the research papers to say, does this species occur in that country? Or sometimes a company might go out and look for it and say, look, we did a survey and we found that you actually have it here. It's just no one's ever researched it before. So we're talking now about indigenous species. So there's various categories that allow you to take a different approach. So you've got a microorganism that's been applied at similar or below levels that commonly occur in the natural environment, and there's no secondary compounds. Then you're going to see a very short rationale for the waiver of data on the effects in the environment, but also the effects on non-targets. You can argue that there will be no effects if you're not significantly adding to the microorganism population. Then you can think about, you're applying things that are significantly above what you'd have in the natural environment, but no secondary compounds. What do you do then? Then you want to provide information about what happens to the microorganism. This is the biology and ecology. Will it establish? Will it grow? Will it persist? And what we usually find is that the microorganisms are degraded and break down by natural biotic and abiotic process. You know, UV light kills them, desiccation kills them, and then there's other organisms which will use them as a food source, and so that they'll slowly degrade. And as an applicant, you want to think about, well, how do I demonstrate this slowly degrading? So a very simple way could be, you've taken some soil, you put your microorganism in it, and if it's an insect pathogen, you add an insect and you see when that insect doesn't die, and that gives you an indication of how quickly the microorganism is no longer effective. So there's some quite sort of simple studies you can do, but as an applicant, you need to think carefully about it. And as an evaluator, you'll see that kind of evidence put forward to support a reasoned case. Then there's the other category that you're applying things to similar or to below background levels, and there are secondary compounds. And this case, then you need to understand perhaps what's the toxicity of those secondary compounds, and whether those secondary compounds could have effect against your non-target organisms. And then if we work through this a little bit further, you've also got, again, applying microorganisms significantly above natural levels and relevant secondary compounds. And this is a situation where you start to see you need a lot more studies there to show that you're not having a significant effect. And then you start to be thinking about what effects that you'll have on the non-target. So in all of this, if there's no microorganisms above background levels, then if there's no toxicity, and you don't have a concern for the soil, it's not all air or water, you can't then have an effect against your non-targets. So this argument about what happens in the environment leads you on to understanding as to what you need to do for your non-target organisms. And then you've got this sort of category where there is no information and there's relevant compound. Now you have to do a lot more work as an applicant, and as an evaluator, you expect to see a lot more information there. So I've sort of summarized what is quite complex, but hopefully quite logical. It's this tiered approach, is sort of saying, and starting with, can I start at this easier level that is similar to backgrounds, no secondary compounds, and you slowly work your way through and say, what complexity am I here? What am I dealing with? And then applicants think in that way, and evaluators sort of should have the evidence. So basically, the more complex you become, the more evidence that you need to present. And I just want to pause a little bit there to see if there's any relevant questions come in.
Yeah, thanks, Roma, and thanks for that start as well. It's actually quite nicely, I think, that, as you say, going sort of simple to more complex, and it's really nicely set out. We have a question here. What if the nature of the microorganism changes over time? That is a mutual interaction with plants into a pathogenic interaction, or saprotroph into pathogenic. How would the fate and behavior of the microorganism be assessed?
Well, so if you've developed a biocontrol agent, you're very unlikely to develop a biocontrol agent that does that, because it stops being a biocontrol agent. And if we think of this in terms of evolutionary terms, what you're describing is exceedingly unlikely to happen. That's why you have to understand the biology and ecology to know that. So that information should be in the biology and ecology part of the dossier. And if you have a microorganism that has a propensity to do that, I would suggest it's not something you should be developing as a biocontrol agent, because it stops being valuable as a biocontrol agent. But I also say these microorganisms we're working with have been under a lot of evolutionary pressure for a very long time and have become what they are. The ability to change is not such a ready ability. To become a pathogen, say a pathogen of insects, is an incredibly complex series of processes, and there's multiple things going on, so we don't really expect it to change.
Okay, great. A couple of other questions. The FAO toolkit, I mean, I know I did hear you say, be patient, it's coming. Do you have any idea around how long that will be?
For the microorganisms?
Yeah.
I'm afraid to say that is as quickly as I get the work finished. So I'm doing that at the moment, and not FAO's fault. It's me who's been a bit slow. I need to get that finished. So yeah, that's what I'm actually actively
maybe within the next 6 months is what we're.
Oh, absolutely. Yeah.
Okay, so that gives us a bit of a time zone. And another question here. I mean, you said here that certain types of microorganisms could be considered for reduced data requirements.
Yeah.
And I guess the question here is, would this be written as a requirement? However, like, do regulators have the choice to actually decide that they can do reduced data requirements, or would that have to be written in the sort of rules that they can choose at an individual level?
Yeah, so if you're working with this FAO guidance, WHO FAO guidance for microbials, botanicals and semiochemicals, this is advice that's in that document and is considered advice. And that document was developed in consultation with regulators globally, not just in sort of Western Europe, but across the whole world, to think about how to do it, because there's a lot of microorganisms we use in biocontrol that everybody knows a lot of information about.
Yeah.
And we just work through and say, are there real risks from these? Where do the risks lie? And as a group, we worked that through and thought, well, actually, there's certain microorganisms where the risk is much, much lower. So I'd really encourage evaluators to look at that and say, can they take that approach? But to take that approach, you have to have good information on the identity, good information on the biology, ecology. But it's a realistic and well-considered approach. And some of the background for being able to take that approach is we looked across at dossiers that had been developed in other parts of the world and looked at what the endpoints were for certain types of microorganisms, like a trichoderma or a metarhizium or Bavaria. And what we found was that depending on the production process, if there's no secondary compounds present, there actually was no adverse results in any of the studies that had ever been done. And that says so we have the evidence to say this is a really reasonable approach to take, and to really encourage evaluators to look at that and to simplify the process, because then we can move the regulation really isn't a barrier, and we can move on to delivering products to farmers. But it's not compromising safety, it's using the evidence we have to make those good decisions.
Great, thanks, Roma. And I'd be keen to hear from anyone in the room. If you don't be shy, but if you're actually have experience in that particular aspect, I'd love to hear your thoughts and your experiences around reduced data requirements and what you're doing in country, or your experience if you're an applicant as well would be interesting. So thanks, Roma.
Okay, all right, I'll move on now. So all that information was about indigenous species. Now we're talking about non-indigenous. Now, if something's non-indigenous, it does represent a higher risk to the environment and to non-target organisms. And in some countries, there's just an absolute no, you can't have a release. And in other situations, that you can have a release, but you have to provide an awful lot more information. You have to really understand its biology and ecology, because the risks do go up as a non-indigenous species, and thinking about what happens when I introduce a non-indigenous species. So technically it's possible to register a non-indigenous species. I've actually never seen that done, because because most of biocontrol agents are so incredibly common, but two, because the amount of work that would be needed to do that starts to make the cost of developing the dossier prohibitive versus the market size for having a non-indigenous species. And then the other thing to think about is, for environmentally fatal behaviour, is that the insect pathogenic microbial control agents are really a special category, because they're only affecting insects. But what you do need to think about is, will this microorganism affect bees, and how should it affect bees? And so for insect pathogenic microorganisms, you may want to do a little bit more thinking through about bees. That doesn't mean to say you need to do more studies, but as an applicant and evaluator, you need to think carefully what happens with bees. And what I often see in a dossier is you get advice on a label which says don't apply whilst bees are actively pollinating, but that only comes as a result of seeing that your microorganism actually did and was pathogenic to the bees. As I say, a lot of these pathogenic organisms are quite specific in their target hosts. So just because you're insect pathogenic doesn't mean you will be pathogenic to bees as well. But I do think it's something that you probably need to just check. As an evaluator, you might well see a study put into the dossier because the applicant just wants to be thoughtful. But again, don't assume because you're an insect pathogen you will kill bees, but you need to think that through. So talking about the non-target organisms, so as we've sort of led into, you can only have an effect against a non-target organism if you're in that environmental compartment. So if you're not in the water, there's no point testing non-target organisms in water, because nothing's going to happen. If you're not in the air, there's no point testing non-target organisms in the air. So again, that really leaves you thinking about non-target organisms that are going to be in the soil environment. And then what you have to think through is what are the non-target organisms that you want to test against. So what an applicant will do is, going through that decision tree, will sort of look at, am I putting an amount of microorganisms significantly above existing background levels? If the answer to that is yes, then you have to think, okay, in that environment, which microorganisms might be more effective? So you might think about, you may not want to test a lacewing, which is on the foliage, if you're putting it into the soil. insects, for example. But you do maybe need to think about things like Alocara or a soil invertebrate that's in the soil. One thing you certainly do not need to do is test earthworms, because an earthworm would not survive in the soil for long periods of time if it couldn't stand being exposed to microorganisms. So really, earthworms are out of there. It's just maybe thinking about some of the non-target invertebrates that you might want to think about. Now, we're talking about non-target organisms. If we go through and think about fish, you don't need to do those because you haven't got the microorganisms in the water. Then you think about birds. If the microorganism is not pathogenic to birds, it doesn't matter that the birds are exposed to it, because it won't have an effect on them at all. And some of the arguments you might see for birds is, for example, the temperature growth profile of the microorganism. So birds have quite high body temperature. So if the microorganism won't grow at that higher body temperature that birds have, then it can't be pathogenic to the birds. You have to think a little bit, if there's a secondary metabolite there, would it have an effect on the birds? And sometimes you see dossier where there's tests on birds. But again, I don't encourage you to go and do the testing. It needs to be thought through and think, do I have an exposure to birds that is at much higher than background levels, or do I have a secondary compound there that thinks that I do need to test against birds? And I sometimes hear people saying, but what happens if a bird eats an insect that's been infected by the microorganism? Well, insects are constantly being infected by microorganisms. There's two things. Some birds just completely avoid an infected insect because it doesn't taste very nice, so they don't eat an insect which is stuffed full of a microorganism. And the other thing is some birds do that because they don't care, which means that they have an immune system that's not affected by it. So again, it's just thinking logically about existing exposure and what's going to happen. So that's the birds. So then we're left, as I said, with sort of thinking about the organisms that you might find in the soil environment, sort of the things like the soil mites, and are they likely to be exposed, and what does that look like? So what you can often see in the non-target organism part of the dossier, the ecotox part of the dossier, is you'll have a patchwork of information which will be recent cases. Some of it will be studies. Some of it will be cross-referencing back to the biological properties. Some of it will say, well, look, from my environmental consideration, I've not got enough microorganisms to be above background levels. I don't have secondary compounds, so I haven't got exposure, so I don't need to do the study. So what you'll see in this ecotox section of the dossier is a mix of all those pieces of information. And again, thinking if you've got an insect pathogenic microorganism, just a little bit more attention on those, and whether there would be exposure to bees and what that looks like. And again, going back to that list of, whether you've got a microorganism above background levels, below background levels, with or without secondary tablets, and work out where you are on that chart, and then what you need to do in that chart. So it has to be a very thoughtful, reasoned, scientific process to develop the dossier and to evaluate the dossier. If you do actually have to do any testing, there are some microbial test guidelines. I mentioned these before for human health. They're the same series 885 that's been developed by the US Environmental Protection Agency Department for Biopesticides. They're really quite old, but they're the best examples we have. And you have a series of test guidelines for what to do in the environment. And that would be, if you've done that calculation for what should be the background levels, if you're significantly above background levels and it's not going to degrade, okay, what do I now test? And then there's also a series of guidelines and methodologies that you can use for non-target organism testing. But again, I really don't encourage people to do any animal testing without good reason. So you need to be very thoughtful about whether you go ahead and do animal testing. And a lot of them, in my experience, a lot of the dossiers for microorganisms, you're able to make a reasoned case. So that's where I was going to talk about for microorganisms. And before I move on, just let's pick up any sort of microorganism-based questions that have come through. Is any questions there, Alison?
No, not at this point, Roma, but
Okay.
I would carry on, and we'll have some questions for you ready for the next session.
Okay, all right. So what I'm going to, that's where I was going to sort of finish up for microorganisms. And I'm going to now talk about botanicals, which are a little bit more tricksy and complicated. So again, when we start to think about botanicals, those first parts of the dossier about the identity and its properties are really important, and I advise any applicant to design those well and for evaluators to really read those. And when you're developing those, thinking about providing information that will help evaluators for the fate and behaviour, environment and effects on non-targets part of the dossier. So just a reminder, what we're talking about by botanicals and extracts, these are substances that have come from plants, and there may be a whole series of lots of different plants used, and there may be a whole different ways of the plants are grown, manufactured and processed, and then you have lots of different it's a very complex group with lots of different types of botanicals in it, and to help with our thinking, we're trying to divide them in sort of these three groups. There's a group where no components of concern, components where you may have components of concern but you know what they are, and others where you really don't know what they are. And so those three different approaches would also affect what you have to do when you think about e-fate and think about ecotox. So thinking about what botanicals are, so botanical active substance can take really crude extract or something very, very refined. So I know some things which have got multiple peaks of different compounds in there, all the way through to something that maybe almost 95% purity on one compound. And as an evaluator, you're going to get all of those different parts. The real concern is whether there's a component of toxicological concern in there or not, and you're looking for the applicant to have demonstrated that there isn't something of toxicological concern, or if there is, they know what it is and they're going to be able to understand what happens to it. But there's no two ways about it. Botanicals are complex, and there's some really smart thinking needed to work out how to address these properly. But this FAO guideline, there's advice in there to try and help this process. So the critical aspects, because these are mixtures, is the quality of the material, the correct identification, the manufacturing process, the really good definition of the active substance, consideration of whether there's residues, and efficacy. The reason why environmental fate and ecotox is not on that list is, again, because if you're taking something from a plant that's already found in nature, which there's a lot of exposure already, there may be we have a lot of information. We know that it isn't of concern for the environment. And the other thing that we'd encourage, instead of doing new testing, is to look at whether there's information in parallel regulation or parallel advice it can use. So, for example, is there an ADI, is there an adult daily intake value set by FAO that you can say, someone can calculate and say, look, when I release it, I'm going to be below that level, so I don't have a concern. And just thinking that through, that's for human health, but thinking that through for environmental as well. But remembering, yeah, botanicals do come from plants that are found out there, but also remembering that plants are really great at producing toxic substances. So just because it's from a plant, don't assume it's non-toxic. As an applicant, you have to demonstrate that it's not toxic and demonstrate why. You could take a different approach. But things that help in the environment is, again, thinking about that soil, air and water exposure, is if you understand a little bit about the biology of what happens to this botanical. So things that are particularly useful is understanding the breakdown pathways for that botanical substance, and thinking in the way that they can decompose, and thinking about that in terms of soil, air and water, again, is what does UV light break them down? Are they volatilized very easily? Are they so diluted in water that they're at a level where they wouldn't be toxicologically relevant? In the soil, are they, a lot of things in the soil are broken down again by abiotic and biotic factors. So they're broken down by the action of other microorganisms. So the soil is rich in microorganisms that break down volatile organic compounds, and a lot of the botanicals are volatile organic compounds. So there's a lot of information in the literature to give you the basis and justification for understanding that actually this is a really common compound. Nature's used to dealing with it, and here's the evidence to show that that's what's happened. So again, encouraging you to look at the literature and think about this as good scientists, and think about very logically the approach that we can take. There are exceptions. If you've got something you don't know what it is, and you do know that you have toxicity, then you've got to think about, can I synthesize it and radio label it? to be honest, it's almost impossible to do this. So if you've got something that is of concern, I'd encourage applicants to think really seriously about whether you want to take it forward, because the moment you have to try and synthesize and radio label it, your costs are going to go massively high. And do you have a market for something that is going to be of ecological or environmental or ecotoxicological concern? So it's not to say that they aren't toxic, but to say that applicants are deliberately and companies are deliberately developing active substances that don't have those characteristics, because they're trying to provide to growers substances which don't cause unacceptable environmental or ecotoxic harm. But that's not to say that they can't do that. It's to say that companies are developing something that doesn't have that, and then the company must provide the evidence to justify what they're saying. So in terms of thinking about what happens in environmental understanding, what you're looking at is how much is out there already and how it breaks down. And then, of course, this affects your ecotoxicological arguments. So the risk can be considered acceptable when the estimated exposure level as a result of the application are lower similar to natural background levels. And therefore, you can't have an unacceptable effect on non-target organism because you're not putting anything out there that they might not already be exposed to, and then you can avoid having to do unnecessary animal testing. Also to think about the diversity and complexity of botanicals, so that the non-target organisms potentially affected vary substantially, and you have to be very thoughtful again about thinking of which of the non-target organisms are going to be affected. It may not, it may not be the daphne or the fish or the birds, but it might be something else. And the applicant, you need to really think this through and think how you do this, and the approach that you're going to take for this. And then if you do have a component of concern and ecotoxicological data is necessary, think about this in terms of each of the environmental compartments, and think about what studies you do for Daphnia, what studies you in fish, so aquatics, think about the aquatic plants, the aquatic invertebrates, and the aquatic larger organisms, and then again thinking about that for birds, what the exposure would be. There's methods that I said for the microorganisms might give some clues about how to do the testing, because the standard chemical methods will be difficult to follow because you've got a complex mixture. So often what you have to do is adapt the protocol. And again, it's been really thoughtful working with the contract research lab to work out the best way to test the method. So some of these botanical substances, if they're monoterpenes, which are really, really common in plants, they're highly volatile. So you have to think about, well, how do I test something that's highly volatile? So if you're thinking about something like Daphnia, because it's highly volatile, it's going to volatilize. Some things I work with volatilize out of the water surface in 15 minutes. And you think, well, is there any point doing a Daphnia test if I know it volatilizes in 15 minutes? So it's matching up the characteristics of the botanical with which target organism you test. And I think, but it may be more relevant if I've got longer persistence in water, say it takes a few hours before it breaks down or dissipates. What do I test then? And then you think, okay, maybe I do need to test some Daphnia. I do need to think about aquatic plants. I do need to think about fish, just to confirm that I don't have an adverse effect on those. And then thinking about the air environment and thinking, is the amount of botanical I'm putting out there going to be significantly higher than you get from the plants anyway? So you think about a forest is producing terpenes all the time at really high levels, and a lot of birds are already exposed to it without any adverse effects. So again, thinking about what's happening in nature, and then thinking about, again, in the soil, what effect am I going to have when I put these botanicals in the soil, and which organisms in the soil do I need to think about? But you do have this group that I'm saying, this group 3. So these are substances which they do have components of concern. The applicant still wants to proceed because they think there's a good market. And they want to sort of show that, yes, there are components of concern, but these components of concern are not having an adverse effect on non-target organisms. And then, in principle, you're going to have a much fuller data package. There'll be much more studies in there. But again, because you're botanicals, you're having to think about how those study guidelines are adapted for these complex botanicals. You can't just go in and do the studies without adaptation. Usually you have to think it through and work closely with the CRO. And you then, as an applicant, you need to explain to the evaluator what you've done, so it's really clear to them, to help them. So really always explain your thinking and your logic, and be very logical. I always think it's about telling a story and just working our way through really logically and making sure you explain that story really well as to what you've done, so that the evaluator, who's nowhere near as familiar as the applicant is, so you can explain to the evaluator really clearly what you did, why you did it, and what the outcome of that was, and therefore what can you conclude from that. So that's sort of where I was on botanicals. I wanted to pause again.
Great, Roma, and I sorry I interrupted you then, because I was just about to say you've got a few questions.
Okay.
I also like that kind of I guess that guidance of trying to tell a story, really, because if you're working on this product, you obviously know it better than anyone else almost. So you're the best place there to sort of tell a story and to lead people through to a desired result. A couple of questions here. Firstly, just for, is there a checklist or something, that an easy checklist for risk assessment for ecotoxicology that people can kind of check through and tick?
It's not quite a checklist, but again, have a look at that WHO FAO guideline, and it's in that it sort of says what, as an applicant, what things you should be thinking about and what are the more critical things, and then as an evaluator, what are the things that you're kind of looking for. It's very hard to have just a really strict checklist because these are such a complex group of substances, and you'd end up with a very complicated tree and saying do this for this one, this for this one, this for this. So it gives them general principles to guide you through the process of what to do. But in a way, as an applicant, you should be making it easy and understandable for the evaluators, so that they can look at that data and say, okay, this makes absolute sense based on biology and ecology, why they've done this and why they've said this and why this is concluded, and I agree with it or disagree with that conclusion. So not a checklist, but certainly good guidance to walk you through.
Okay, great, thanks. A couple of other questions here is, how is it possible to have a substantial background concentration of botanicals in the environment? ? Contrary to microorganisms, it seems unlikely to have a certain existing level in the environment.
Oh, but there is. So I just gave the example in forestry. If you walk through a pine forest and you smell that lovely smell of pine, those are terpenes. Those are the volatiles. They're all there all the time. So they are producing them and putting them into the air. So there's a background level of the amount of terpenes. And it's the same, when a plant's grown, it produces things out of its roots. And there's existing substances produced in the root area. And when those plants die and break down and go into the soil, nature, we aren't sort of we don't have an accumulation of plants. They're broken down. What are they broken down by? They're broken down a whole series of abiotic and biotic factors, and those abiotic and biotic factors are working on these botanicals that are applied as well. So it's there's absolutely do have background levels for these substances, and there's information in the literature about what these background levels are. And they're really well studied. I mean, the difficulty comes if you're working with a plant which is less well known. So we know lots about neem, and there's lots of people done research on it, but perhaps you might be working with a less well known plant. And then when you're working with something that's less well known, it is harder, and you will have to produce more data specific to your botanical.
Yeah. Okay, great. Thank you. Another question here. I'm interested in matrine and oxymatrine. I've heard there's an issue on it in EU regulation. Is it true? Any updates on whether it controls fall armyworm?
Okay. Yeah, there are some real safety issues in matrine. It's not something that you perhaps really want to proceed with. And as you say, there is information and evidence around by considerations by other regulatory authorities which outline exactly what those issues are. And I think it's something that I think there's other botanicals around that can be developed rather than the tree. So really think about that. So I mentioned earlier about accessing information that has been already decided by other regulatory authorities. So if I was an evaluator, and I had a dossier for metrine, I would expect there to be consideration of what other regulatory authorities have done. That's how we learn. We learn from our peers around us and what good quality work. And so, yeah, it's absolutely true. There is an issue with metrine.
Great, thank you for that. And that's a good point too, is learning from what other regulatory sort of systems are doing and what decisions they've made, and kind of learning what they've looked at. So that's an excellent point as well, Roma. Okay, thank you. We'll move on to the next section.
Yep, okay, so the next section is going to be semiochemicals. And just to say, you know, I'm working through this quite quickly, and that's because we want to have a nice discussion at the end as well. Okay. So so now thinking again about the fate and behaviour in the environment and effects of non-target organisms for semiochemicals. Now this is kind of really interesting for semiochemicals. So again, got to think about the identity and the physical properties, but we have some really nice features of semiochemicals. So the main ones that are used in plant protection at the moment are the straight chain lepidopteran pheromones. These are mating disrupting pheromones, and what the main characteristic of most pheromones and semiochemicals we work with is they're not killing something, they're changing the behavior of something. So this makes them really different when we think about this in terms of environmental fate and in terms of ecotoxicology. So one of the things to think about is insects are communicating all the time. You know, male moths are trying to find female moths all the time. And how do they do that? They do that because a female moth produces a pheromone. So the environment is stuffed full of pheromones. We have no idea because we don't pick up on the signals, we can't smell them. But if you're a moth, it's probably quite exciting. So for semiochemicals, the main way that they're used, or one of the main ways, is mating disruption. And this is the pheromone is released that mimics the female pheromone, and the males can't find the females. Then you break the life cycle because they can't mate, you can't get the next life cycle. There's also some which are lure and kill, where the pheromone's released, and the idea is to attract the females to a certain point, and then they're killed by some means. It could be killed by another biocontrol agent, it could be killed by and getting stuck to something. And then this overlaps with the mass trapping concept, where again you're pulling the insect in. And sometimes for mass trapping, they're using a chiromone, which is a food. It stimulates the smell of food and attracts the insects in because they think it's food, and then they get stuck there in water or on traps or something. So remembering, the interesting part about semiochemicals is they're not killing anything. The other part about semiochemicals, as well as not having a toxic action, they're really target specific. So they have all of their effect only against their target species. So that starts you thinking and saying, well, okay, so for what non-target organisms would I need to look at? And the answer probably is none, because all they work at, they have an effect on, is the target. But what you probably want to confirm is how target specific they are, and you would be expecting to have evidence in the dossier of exactly how target specific the semiochemical is. And that's really easy to do, because usually you only have members of the same species that respond to the smell. And of course, as I said earlier, that the semiochemicals are already out there. The insects are communicating with each other all the time, so they're already there. It's just we can't detect them, we don't know they're there. The other part about semiochemicals is they're used at very low rates. They're often used at micrograms per hectare. They're used at very, very tiny amounts. So you're not putting, you know, litres or kilograms per hectare out there. It's very small amounts. They also, because they are in the air, they move in the air very rapidly and they degrade in the environment. And again, we expect that to do. So for an insect, if it's producing a pheromone, they don't want to produce a pheromone that stays around forever, because then the air gets saturated and the males can't find them. So it's kind of like they produce something that is in the air for a while and then breaks down, and they produce it again. So it's like if you're working somewhere that's you know, in a kitchen which has a beautiful smell, after a while you can't smell it anymore because you've become sort of inured to it. So it's the same with the insects. So to get over that, they have a release, breakdown, release, breakdown. So we know that semiochemicals do dissipate and degrade rapidly in the environment. And of course, the semiochemicals really pose very little risk to human health and the environment as a consequence. Mainly don't have a residue. As we talked about, the efficacy is harder. So, so this makes them different from chemicals, but it also makes them sort of quite different in terms of environmental and non-target risk assessment. So the underlying principle for semiochemicals is looking at the amount of semiochemical that you're, as an applicant, that you're putting out there. So, you put the semiochemicals into little sort of PVC containers, which are spread around the crop. So you look at how much does that contribute to what goes into the air compared to what's there already. I haven't put the calculation into this presentation, but you will find that calculation in the WHO guidelines. But there's a really clear calculation you can do for what is known for or what can be estimated for the existing background level. And then as an applicant, you say, okay, I'm contributing this much, I'm at background levels. And pretty much all the time, you're at background levels. So what you're doing then is you're always looking at the amount that's released by the product that's put out in the field relative to background levels and what that natural exposure is. And remembering a lot of these dispensers are also retrieved. So they're only there for a short period in the crop when the pest is active. So they're not there for a long period of time. Again, this affects the environmental exposure and what's exposed to it. So you need to take that into consideration. Now, if you have a pheromone that is formulated in a sprayable formulation, that calculation is going to change. You sort of roughly take the same principle, but there's every likelihood that you might have a higher exposure, and you then just need to think about it. But remembering that semiochemicals are so specific, they only affect members of the same species. So in terms of environmental fate, in terms of non-target organisms, they're not going to have an effect against other organisms that are out there. And this is the principle of the approach that's taken to an ecotoxicology part of the dossier, is when the exposure to non-toxic is by the vapor phase only, and we're not expecting further information to be needed. And so you'll often see the applicant should have prepared, and evaluators should see is a reason case for the non-provisional of data. Now, as I say, for a sprayable one, you need to have some additional argumentation in there. And the other thing to think about with these semiochemicals is it may be possible to use data that's derived from other regulatory mechanisms that have been using the same substances. So for some of these pheromones may be used in other areas for different purposes. So it's always worth doing the research to find out, again, as much background information, where else they're used, and can you use some of that already available evidence to add your own. I just should emphasize here is you can't use data that's protected by somebody else. You can only use data that's available in the public domain. So that was really where I got to with semiochemicals. I'm just going to take a pause there about the semiochemicals, whether anybody's got any questions, because it's really peculiar that for environmental fate and ecotox, you really don't have much to do for semiochemical. And I'm not sure whether people listening today agree with what I'm saying or the approach that I've proposed.
There's no questions as yet, Roma, but maybe if people could put like you're getting a heart there coming up, but people could also.
I would disagree.
Yeah, put a thumbs up if you're working on semiochemicals. Is anyone working on semiochemicals? Have they seen a dossier? That would be really interesting, because I'm not sure how many in the room actually are. If you are, just put a thumbs up from the reactions.
So maybe it's a split question.
One.
Yeah. Yep. Okay. So one person has worked on. Good.
You've got another question though, Roma.
Okay.
No, have you got another?
Oh,
you're going to ask.
Yeah, I was going to ask the flip side, because what I've been saying about environmental fate and ecotoxicology for semiochemicals is really quite different what we might expect for semiochemical. Is maybe sort of we can have thumbs up if people sort of think it's logical what I've been laying out, and thumbs down if people think no, that we think we need other work. So maybe people could react, both applicants and evaluators, as to whether it's logical what I'm proposing for assessing environmental fate and ecotox. So perhaps some reactions. You should be able to find the little thumbs up and down in your.
So I think there's only a thumbs
box.
Up.
Oh, is there? No,
we're only a positive group here.
So does that
So,
mean no one's replying that you all think I'm wrong?
so put your thumbs up if you think this is making sense, if it
Oh,
seems
phew.
logical, and you'll see that down at the reactions. There we go. We're getting some reactions now. So you'll see that on the bottom of your screen. If you just put your cursor over it, you'll see the black menu come up. You're getting quite a lot of reactions there. So that's great.
Okay. Good, good. Okay, so it's making some logical sense. I'm glad to hear that. I'd hate for it to be to be no logic in it. Good, good. And I think what I'm trying to say, and what I've been trying to say across the whole of this series of sessions, is that we have to think as good scientists, and we have to be good scientists, and we need to think logically, thinking about what the substance is, and thinking what its toxicity is or is not, and then thinking, okay, so based on that, how do I evaluate it, and just telling that very, very good story on what to do. So just moving on then, one of the things I said at the beginning was that there's lots of innovation going out there, and we know that we want to implement integrated pest management, and we know we need a lot of products to do that. So what we don't want is that regulation is a barrier. We want regulation to protect humans. We want regulators to protect the environment, but it shouldn't be a necessarily high barrier. So what can we do to make sure that regulation is working well? So I think you can have a dedicated scheme for bioprotectants, and you have people who are skilled in the technologies to understand it well. I think we also have expert evaluators. So the applicants need to be good at what they're doing, but the evaluators also need to be good at what they're doing. They need to understand the scheme. So the dedicated bioprotectant scheme is something that governments can do and set up to encourage the pull through of these technologies. And as we can see from the people who are attending these sessions, we know that there's people out there who want to gain expertise and become these expert evaluators. I think then it's really important to have a clear process, from right from the beginning all the way through. And for me, regulation works really well when there's a good partnership between the applicant and the evaluator. It's not so the applicant can influence the evaluator, it's so the applicant can explain well what their technology is, and give the evaluator the sufficient evidence to make their good decisions. And also thinking, there's a lot of time I was to say you don't need to provide data when. But that doesn't mean the applicant can't explain it, but it's a really good principle, so that then the evaluator is only given the information they need to allow them to make a good decision. They're not swamped with data which they have to read and have to evaluate, but doesn't help them make a good decision. So it's been really thoughtful about what the right pieces of information to provide are. And this trusted engaged partnership. So as an applicant, you want your product to be approved, and as an evaluator, you want the product to be approved because you want to get solutions to pharma. So we should trust everybody. We should trust applicants, we should trust evaluators, and we should trust our colleagues within our departments, within our countries, and in other countries, and trust the evaluations made by other authorities. It can often save us an awful lot of work. And if we work into the same standards, this really, really helps, that you have this harmonisation where everybody's trying to work to the same standards. And I know I'm sort of based what I've done on the WHO FAO guideline, and that's because that's an example of a harmonised standard that we could all work to. And it was developed very thoughtfully with a wide group of people and taking sort of quite deep experience that had been learned. And then sharing of data, that we don't need to always produce new data, that you can share data with each other. That's between authorities. And then I think if governments can instigate innovation enabling policies, which are supporting the regulators, they're supporting the regulators with allowing them to gain the expertise, supporting the regulators with enough staff, and supporting the regulators by funding them well, and not having fees that are too high for the applicants. All of these things that governments can do to enable that innovation to come forward. And we can see in countries like Brazil, where this happens, that they have far more biocontrol products than anybody else in the world. What I don't underestimate is that all these biopesticides, whether they are microbial, botanical or semiochemical, it's much, much more complex, and this is what makes them harder. So your dossier may have less paper. So if I put together a dossier for a microorganism, it may be, I have a sort of meter-high stack of paper, which can, if it was a chemical, you'd have 20 meters high. So it's a lot less paper, but it's very knowledge intense, and it's a different type of knowledge. So it's knowledge and information about soil ecology, plant ecology, the landscape, the microbials, genetics. It's all of these other different disciplines that need to come together. And this is what makes the dossiers harder just to assess, because you've got all these other parts. But that's what WHO, FAO tried to do, to simplify all of this knowledge into a way that is pragmatic for applicants and for evaluators. And yes, we still do need some knowledge of chemistry, and we're not moving to a world without chemistry. So that's more or less finished for today's presentation. But what I wanted to do is go through some of the questions that have been raised through the sessions, and maybe take some time to look at these, but also then to take some time to raise questions from today. So I think I'd first start with the questions from today, Alison. If anything else has come through, and if not, then I'll move through to thinking about questions that have been raised through this series. And if people can start to think and put into the chat any other questions they have.
Thanks, Roma. Yes, I'm just going to encourage everyone, put your questions and your burning questions that you want to ask Roma while you have her here. Anything is acceptable. There's no silly or stupid questions here. Probably your question is somebody else is thinking the same thing, or wanting an answer as well. So please just put it in. It's just great to have a discussion. Really interested in hearing from regulators, but also applicants on those sort of things that help build a really robust system. So it was really nice, your list before, Roma, where you had the different components that helped build here we go, a successful bioprotectant regulatory sort of system and capacity. So I'd be very interested in hearing from you all on any of those aspects where you think you need more help too. So please put in the chat where you think you would like more support, or if we were to design a specific program for your country or for stakeholders, it could be regulators and applicants in your country, because that was one of the important points, was can we work more together? If you would like something like that in your country, please say that in the chat if that's something that you think would be really useful, for example, in Papua New Guinea, or whether it's in Singapore or anywhere in the region. We're really interested to hear if you need some support there to help build capacity and capability. So please share that with us. We're not listing everyone's name against the feedback. It's virtually anonymous, and we won't be sort of collecting those names against any questions. A couple of questions, Roma, before we move on to those questions that were raised in the SurveyMonkey poll. Yep. So if you were, and I think I've asked you this before, but if you were to advise, I guess, regulator, I mean, what would be your top 3 tips for a regulator when they get a dossier on their desk?
Yeah, okay. So the first thing I would, regardless of whether I'm a ecotox specialist, environment specialist, first thing I'd look at is the sections of 1 and 2. Has the applicant identified this really well? Is it really clear to me what information as to what this is? Have they, for microorganisms, have they sort of put sufficient information on its taxonomy, on its secondary compounds, and then thinking in the mode of action, have they described that really well? And the same true for botanical. Have they identified it properly? Do I understand what this substance is that they've extracted and they've found? And then have they put in good information that explains where it came from, how they expect it to work, and what it does? And then the same for semiochemical. Is it clear what this is and how it can be used? Because if those parts are done very well, the other parts of the dossier are much, much easier to understand and handle. And it's sort of, you're thinking of that tiered approach, thinking, okay, once I've got my foundations right, then it's sort of saying, okay, I can see why they've said they don't need to answer these questions or these questions. But as an applicant, never say not relevant. You must explain why something You don't, it's what it's called is a reasoned case for non-provision of the study. And that reasoned case should be really well done. And so as an evaluator, I'd be looking for that really well done. And that's good evidence. And that evidence isn't just because you say it so as an applicant, it's because there's information in the scientific literature, good quality information, good quality published papers, or you've done good quality studies yourself. Say you've worked in partnership with a university or a research institute, and you've got a really lovely study report, which is dated, authored, with all the information in it. You know, what was the aims, what were the methods, what were the results, what were the conclusions, and it's a good quality piece of work. And you're looking for that quality that should be done. So quality doesn't mean quantity; it's quality is the key issue.
Great, thanks,
So,
Roma. And I think you gave a tip there for applicants as well, not
yes.
to skip any sections and not to put not relevant. So that is actually very useful as well. And we've got a question here. In Brunei, it's really a grey area when it comes to regulating biopesticides. Could you summarise for us the details that we need to consider or review when a company wants to bring in a biopesticide into the country? And we actually had a similar question around importing as well in our feedback from the monkey survey. So it's a good chance, good question. Thanks, Lucia.
Yeah, it's a really good question, because you've got two parts, haven't you? You've got somebody who's in the country who's developed a dossier, but you've got somebody who wants to bring it in. And again, the WHO guideline actually does address this, and what it's trying to help is both of those situations. So if an applicant's coming to me, I would want to meet the applicant. I'd like to understand what they're doing, and I'd want to understand and hear them describe well what the substance is. I would be looking in that dossier that they've completed all the parts of the dossier. But when you get a chemical, you've got a series of endpoints there, and you can just go through and check all those endpoints. And clearly, when you're dealing with bioprotectants, you're not going to have endpoints in the same way. So it's much more of a value judgment. So I would check that the company owns the dossier that they're bringing forward. I would think where that dossier has come from. Has it come from a country that follows the sort of OECD principles, because then it's going to be good quality. If it hasn't come from such countries such as that, has it come from another country where the regulatory process is a good quality regulatory process? And you want all parts of that dossier there. There's nothing missing. It's not just the conclusions, it's actually the dossier, so you can go back and you can cross-check the conclusions against the evidence that was produced in front of you. It should be complete. There shouldn't be missing parts to it. And this comes down to this trusted, engaged partnerships, is as the evaluator, that you've met the person who's evaluating it, and you've learned to trust what they're saying and doing as well. And it might be something you need to think about as sort of sitting in Brunei thinking, okay, so which countries' dossiers do I think are good quality that we would accept, and which countries' dossiers might we have some extra questions about, and to just think through. But I think if you use the WHO FAO guideline for the microbials, botanicals and semiochemicals, there's guidance in there on how to do this and what questions you should ask. It's not going to be a checklist because it's a biopesticide, but there's sufficient guidance to say, okay, this is where you need to be concerned, this is where you don't need to be concerned.
Great, thanks, Roma.
I'm not sure if that helps, so come back to me again with a question if you think I haven't.
No, I think that does. I mean, I think the important thing here, I mean, I really liked meet the applicant. I actually said meet the application. Sorry, everyone in the room, but then I put meet the applicant. And I think that's really important, because that does build trust as well. When you meet people, you talk to them, you understand if they know what they're talking about. I was interested in check the ownership of the dossier. Is that because sometimes people put dossiers that are not theirs in?
Yes, so sometimes people will rely on dossiers that they don't fully own, they don't have. So you need proof of ownership. It's called a letter of access. So you would expect to see a letter of access that can, if a dossier was developed by another company, you should have an official letter of access to say that the applicant has the rights to access that data. And I have seen dossiers being put forward where that is not the case.
Okay, Okay, good point. Good point to know. A question here for semiochemicals. Do the slides look at all the types of pheromones or only specific pheromones?
I was thinking about all the pheromones that are released in slow release containers. I think I mentioned that if you're spraying a semiochemical, that some of the things you need to do a little bit more extra work because of where the pheromone occurs, what its breakdown might be, and you just need to understand a little bit about the formulations and the slow release formulation for a sprayable, and then you've got different exposures, etc. But for something, most pheromones are put into things like PVC little tubes or something like that. and I was thinking across all the pheromones when I was thinking about the regulation. That's to say, doesn't mean that somebody's going to invent something tomorrow that is very different. We've always got invention, but I think the guidelines have got the flexibility to account for something that's newer.
Okay, great. Now I asked you this, but in a different way in a previous session, but I'm just interested in thinking about the sort of, what do you think regulators mostly see? What are the most popular sort of applications, do you think? And how is that changing over the last 5 years?
Yeah, I think most people will see, I would say over 50% of what comes through is based on a microorganism, and maybe even 60 or 70% is going to be microorganism. And of the microorganisms, the majority of those will be microorganisms active against diseases. And then there's a whole group will be microorganisms active against insects. I say that sort of, well, most evaluators will have seen a BT dossier, microbial BT dossier, for sure, because BT has been around for such a long time. But if you put aside BT, then I'd say you get a lot that are for disease. So you'll see dossiers for trichoderma, for Bacillus anaplasmosis or sort of subtilis. They're really common. And then for the insects, you'll see dossiers for Bovaria, for metarhiziums coming forward. As well as BTs, then you'll see baculoviruses. Those are the most common microorganisms. Then coming after that, probably the most common botanical ones will be for neem. And then the terpenes, so things like limonene, terpene itself, geraniol oil, so the essential oils, they're quite commonly coming forward. And then pheromones slightly less.
Okay, and the change over the last 5 years, what do you see in the next 5 years? Actually, that's even more interesting in a way.
Yeah, I think, yeah, so what we've seen so far is kind of the easy things. I think we're going to get the more complexity coming forward. So we're going to start to see sort of for the microorganisms, what we're seeing is viable microorganisms with or without secondary compounds. We're going to start to see some dossiers where the microorganism is no longer viable and you're relying on the secondary compounds. And again, that's foreseen in thinking about regulation, but I think we'll see more of those come forward. Then botanicals, we'll see extracts from a wider range of plants coming forward for a wider range of uses. And what I really hope we start to see coming forward is dossiers for bioprotectants that are active against nematodes and against weeds, because so far there's very few of those come forward. It's mostly against insects and diseases. And I think we'll see an explosion in semiochemicals. We're going to see a lot more semiochemicals coming forward because they're just so useful for growers.
Yeah. Well, that's actually very interesting. And I think that gives a heads up to all our regulators and our applicants who want to be applicants, maybe to be on the lookout for those things. And as you say, it might be in some ways a little bit more complex because they're new. And other ways, I guess, with sort of, if we can fast track some of these bioprotectants, it could also be less complex if we can build the right capacity and capability around good applications and good regulation. I've got a question here, and it starts off, not sure if it's a silly question. As I said before, there's no silly questions. So, but should a microbial biopesticide coming into the country be tested under lab settings to confirm the presence of the microbes listed in its ingredients? Sometimes the labels do not list its microbial content in detail, trade secret.
For an evaluator, you've absolutely got to know what the microorganism is. And I noticed the use of the plural word microorganisms. Most dossiers coming through will be single microorganisms. If it's multiple microorganisms, I would want to see the active substance information for each of those microorganisms separately, properly identified, well identified, and then maybe in the product they're combined. You absolutely, as an evaluator, how on earth can you follow and make a successful evaluation if it's not correctly identified? I think I made that point in the first session. The key part of the dossier is that the identification of the microorganism, and it's fully and correctly identified. So, yeah, I don't advise mixtures. You can do, but you need to fully identify each of the microorganisms that's in there. You also need to provide good information on any secondary compounds that could be present, and that comes from looking at the production process as well as having evidence for that.
Great, thanks, Roma. Now we'll just there'll be more questions coming through, I'm sure, but if we just move on, we've got a question page, everyone, and we've collected some questions, and there's some very diverse questions, and Roma's going to give her best shot at answering some of them, and some of them we'll be answering in other forums maybe as well. So it may not be this is the right forum, but I can, for example, say that controlling fall armyworm, different bio products will be in lots of different workshops, and you can actually go to our videos page and there's quite a lot there as well for examples. But I'm going to hand over to Roma, and maybe you can choose a few that you like, or you can move through, but I'll leave it with you over how you want to proceed.
Okay, I'll see what I can do. Okay, so I'm going to start at the top just to be logical. So what barriers, law or pharma, affect the use of biocontrol? So this is the use at the end. So I think I've already hinted that we don't want regulation to inhibit the availability of the biocontrol. So we do have a barrier if we have regulators that are not given the resources, and by that I mean time and knowledge, to be able to assess the dossiers. So that will affect what biocontrol can get through to the farmer. And then the difficulty we have with biocontrol is, well, it's a great group of technology, and we're at the beginning of this sort of, not quite a revolution, but an evolution away to a more complex way of carrying out crop protection, which is an integrated pest management approach where you're using all the technologies and thinking, how do I help the plants grow as well as possible but manage the disease? We're not trying to kill everything in sight, we're just trying to manage things well. And there's an explosion of knowledge and evidence right at the moment. So what makes the use of biocontrol harder is that knowledge exchange, is how do you train the farmers in this knowledge? How do we train the advisors and the agronomists in this new knowledge and how to use these technologies? And I think some of the responsibility sits with the companies, is that companies should be providing the good information with good labels and good advice on when to use something, how to mix it, how to spray it correctly, and just really provide a lot of support for the farmers. And when that knowledge chain is incomplete from the applicant through the regulator to the farmer, that's when you have a barrier. So it's look at all those aspects and make sure that all those aspects are working well and resourced properly, and then you can see biocontrol moving forward. And the countries where it has moved forward, that's what's making it move forward well. Then thinking about how many species of microorganisms are used for biocontrol in rice plants. Very few. There's not many. And again, it's interesting that I think that's not because it's not technically possible, it's because people haven't been looking at it and doing the research. There's no reason why there can't be more microorganism products available for use on pests and diseases in rice. And you know, if I don't know if someone from IRI's here, but we know from the fall armyworm work, Alison, that we know that IRI are working on this, and I know other big research institutes are working on this. So it's just lack of research rather than lack of technical feasibility. And I think we will, if I encourage researchers to start looking at this, I think we will see biocontrol solutions for pests and diseases on rice plants. I know something from rice blast, for example, that's a botanical, but it's just been slow to come through. and I do know some microorganisms which have an effect against, say, plant hoppers, but again, they're not being moved through. Because the other thing you need is, well, not technology, is you need the companies to bring them through, to see that there's a marketplace. And if they've got sort of competing against cheap pesticides, what's their incentive to start to invest and bring biocontrols forward? And then the question about what mechanisms in place for Papua New Guinea, for example. I don't know the answer to that, but I wonder if there's anybody who's on this call who is from Papua New Guinea who could answer that, and maybe just say what actions they're taking to gain knowledge. And I would think the fact that you're here today shows that you're starting the process of building knowledge to be able to regulate biocontrol agents. So maybe somebody wants to put into the chat and answer that one, what mechanisms are in place.
No, but we'll come back. It's a good question, and we'll find out for that one. And I think the next question too is around Papua New Guinea. So Papua New Guinea, just if you, we're going to find out that question for you and come back over the next week. So thank you for the question.
I think that's a good one. Yeah, it's a really good question. So then we've got a question about how do we identify the strains of bacteria, whether we need the same microbe to undertake field experiments or different manufacturers. I think this comes from something we talked about in a previous session. So how to identify the strains of bacteria. So in the past, traditionally, we would do this by following a series of tests where we're growing the microorganism and we're following a series of tests on plates, and we're subjecting them to what's called the Berge's manual approach. That's really kind of not done so much now, and what we have is we have good molecular techniques for identifying strains of bacteria. And if you don't have that resource in your country, reach out to researchers around the world who are skilled in that particular organism and work with them to help them to identify the strain. It's actually really inexpensive to do, but what you then do is you follow a technique, usually it must be a published technique on how to identify the strain. So when a strain gets identified by a molecular technique and is sort of officially registered as or logged as that technique is published, and then you can copy that technique and use that same technique to identify a strain. But if you haven't got the resources to that, you can send your strains to one of the international tissue culture collection laboratories to do it. You could build up a relationship with the a university team who's expert in that particular organism, and then they'll have the techniques for identifying it. So you use a molecular technique that is standard for identifying the type strain of that species, and then you look at where your strain sits relative to the other strains of the same species. So you want to use a good molecular technique. The regulation isn't prescriptive of which method you should use, because each microorganism you usually need a slightly different method, and you follow the method that was used for the original identification. So do we need the same microorganisms to undertake field experiments from different manufacturers? That depends. No, each microorganism strain will perform differently from another strain. So what you're doing then is looking at which is the best species and strain for my pest or disease. And the starting point for that would be to do some literature research to understand that. And I think I see often that people will sort of say, oh, I'll go and find my own strain. And I just want to say, well, that's a really, really expensive approach to do that. I think the first thing I'd ask is if I had a pest or disease that I wanted to get a biocontrol for, I would test what's already available, that's already been developed, is in the manufacturing process for which there's a dossier, because that will get to market much more quickly, because what you're doing is you're adding a label extension as opposed to starting right from the beginning. So screening, always start with what's commercially available, and if none of those work, then perhaps you need to start to think about developing it yourself. But if you're going to develop it yourself, as you'll see from the research series we're doing, that's going to take you 10+ years before it's in the hands of the farmers. Then moving on to the next question. So what key aspects regulators must take into consideration when allowing imports of biocontrols? So I think we've gone into that. We've talked about whether something's indigenous or non-indigenous, and there should be a good dossier available that the evaluator, the regulators can evaluate to see that all the key questions have been asked, and that the there's good and sufficient evidence allow them to make that risk assessment decision. And then somebody else was sort of quite different, working on parasitoids rather than beneficials. So mostly I've been talking about microbials, botanicals, semiochemicals, so as bioprotectants, but there are beneficials used. Now, the regulation for the beneficials is usually around plant import and export rules, and they have rules about what you can do, and most of the work for beneficials is regulated by those rules. There are a few exceptions. So, for example, in Kenya, they have 2 levels. You have to go through the plant import and export system, and then you have to actually register the beneficial. But that's an exception. In most countries, you just have to go through the import and export rules for the beneficial. The fall armyworm, I think, as Alison indicated, that is something that is addressed very fully in the fall armyworm project, the ASEAN fall armyworm project. There's a lot of information about what biocontrol products are available and how they're to be assessed and what are the attributes of those substances. So I'd really advise you to go and look at those other resources to answer that question. How can we best access the latest updates from biocontrol regulation? Well, being very cheeky by attending these masterclasses. I've indicated to you that the latest updates about biocontrol regulations, that WHO guideline. You can look at what's happening in the US with the biopesticide scheme. It's harder in Europe because they don't have a dedicated biocontrol regulation page or information, so it's harder to find it. But some of the trade associations, so like the International Biocontrol Manufacturers Association, has the latest information, and then the sister organization in the US, the Bioprotection Industry Alliance, and they all sit underneath an umbrella called the Bioprotection Global. And if you go onto that website, you'll find information about these producer organizations, and they often have nice up-to-date information about what's happening in biocontrol regulation. Then I'm just next question. I work on biocontrol for a perennial crop. This is a really interesting one. I understand that populations of microorganisms in the soil are transient with time and environmental conditions. So in what way can biocontrol agents be used in perennial crops? Really interesting question, and I think that's something that we will see more and more of when we're looking at how to use microorganisms to manage pests and diseases in perennial crops. But it's not so different from a chemical. It's repeat applications is the answer. So it's understanding the microorganism and when it works and how it works, understanding how long it persists for, and looking at the interaction of the pest or disease population with the interaction of the substance that you put in. So you're putting your biocontrol agent in when you have your peak, the right life stage of your pest and disease target. Of course, the pest and disease populations are not so synchronous, so you might have to have 2 or 3 applications to reduce the population. But there's definitely work going on there. There's information in the literature you can find out about that. But as a researcher, I would be looking to understand my pest and disease life cycle and then how I coincide that with the microorganism. And then you'd probably have repeat applications. And then the last question then is about Papua New Guinea, about cocoa. Is the cod borer, cocoa pod borer is the main problem. And what's the potential for using biocontrol? I can't answer that now. I'd have to do some work on it. So I think that's one we need to come back on and do some research about what biocontrol is available. But a good source of information to get you started would be to go and have a look at the CABI website. There's a really good, CABI have got a really good resource for pretty much all the pests around and diseases around the world, and then they have a list of what the biocontrol options as well as the chemical options and what you could use, and they really keep that up to date, so that would be a really good starting point.
Great,
Alison, that's
thanks.
answered the questions then. Is there anything else
Yeah,
coming?
no, yeah, there is, Roma, and thank you very much, because that's quite a big list and some really interesting questions. And we will follow up, and we'll also share some of those resources about the latest updates, just some of those websites for you to go to, IBMA and also in the US, for example, just so that you've got them in one place. You have got another specific question here, and I'm not sure that you know much about leaf miners using semiochemicals. What could be
Okay,
your
I
most
do.
appropriate approach to control leaf miners using semiochemicals is the question.
Oof. Yeah. Okay. So is this a leaf miner on tomato? Would it be tutor absoluta? If someone could put their thumbs up to say that's maybe what they're thinking about. So for semiochemicals, yes. So I think what with a lot of the biocontrols, it's not about, they're not substitute chemistry, and you can't just use one solution to have the effect that you're having. You're having to layer these in as an IPM. So you would be using a semiochemical as part of a strategic plan. And it's the question is, would you use the semiochemical to draw the insects into a trap, and you're trapping them out in that way? Or are you using the semiochemical to disrupt the mating behavior? Both of those are quite feasible, and there's pheromones available to do that. And then you'd be combining that with using a biocontrol agent at the same time. So it would be working with those pheromones in combination. I'm not sure that's a complete answer, but hopefully it gives you some guidance as to where to look for how you could use the pheromone.
Great, thanks, Roma. And that's the end of our questions at this point. I just want to say thanks to Ewa for sharing. She's just shared some an EPO paper on biological control agents safely used around beneficials. So thank you for that.
Really helpful.
Yeah, that's really great. And we'll also collect those sorts of resources and put it into a final resource package for everyone. So look, there's been a lot shared across these three sessions, a huge amount of detail. Roma, just a massive amount of work and slides, I'd have to say, and information packed in each slide as well. And you've done a fantastic job. Just before we end, I'd just like to really thank Valent Biosciences and Sumitomo Chemical for their sponsorship of the whole series. It's fantastic to have that support. And really, it's a really useful platform foundation for going forward and working out, okay, now specifically, how can we work to support you all in this important area of work and regulation of biocontrol, because it's critical to actually making sure that farmers can have biocontrol and use it. And just so everyone is on the same page here, everyone needs support. So it's definitely not any indication that you've got a weaker system or a poorer system than anyone else. Even the strongest systems, there's always ways that we can improve, because it is a really complex area. It's changing. As Roma said, there's new exciting developments coming through in the next 5 years as well, that things that you may not have seen before. Great to sort of check with others to see what they're doing and actually find out ways you can make improvements or actually get support. So we're looking forward to working with you all over the coming months and thinking about what we can do further to really help you explicitly in some aspects of your regulation where you think you could need a bit of support. Roma, thank you. I'm just going to leave it. Roma, maybe a last statement from you would be good before I close it. So I'm going to give you back the floor.
Okay, lovely. Alison, thank you very much for doing it. Yes, I've really enjoyed doing these sessions. What has really impressed me most was just the level of interest in biocontrol and the level of engagement in this. And I'm hoping that what we've done is to stimulate everybody to have a conversation with each other, because I think the more we can share knowledge, the faster we can move forward. And I really have been really impressed by how many people are interested in biocontrol. It's really great to see. Thank you. Yep. And thank you for inviting me to take part in this.
No, you're most welcome. It's actually a pleasure to have you on board, and we're really privileged to actually have your expertise really helping to shape our work. So thank you to everyone. Thank you, Putra, in the background there, also helping out. And I'd like to wish you all a a good rest of the day, but also a good week in front of you, and we will see you back, and I will be in touch personally with you all via an email with all the resources, the video, and to follow up. So thank you so much. Thank you, everyone.